Hello students, the next section that we're going to go into is we're going to be looking at exponential growth and exponential decay. So exponential growth means our values get big very quickly. Exponential growth means our values get small very quickly. The graphs are going to look like this, climbing up very quickly, or look like this, they're going down. They can also be flipped, so they could be coming down like this, or they could be coming the other way as we look at it. So these are our graphs. These are what we're going to be doing is we're going to be looking at how do we graph exponential. We looked at graphing linear equations, we graphed quadratic equations, cubic equations, and so now we're going on to exponential. So a couple things we're going to go through. We're going to be using this equation up here. So please take note of that. G of x, or y equals a times b. X minus h, notice x, or our h value is minus up here, and then our k value. So what we're going to do is identify a, b, h, and k in our equation. We're going to identify the horizontal asymptote. The horizontal asymptote is our k value. And then we're going to graph the points. We've got two reference points. This is what we call the first reference point. It's the one closest to our asymptote. And then our second one that's further away as we go forward. So we'll start off with number one. We're just identifying a, b, h, and k. So our first value in front of that parenthesis, that's our a value. Our b value is our base, what has the exponent attached to it. Our h value is what's in the exponent, so it's minus 2, so that's actually a positive 2. So just remember h is opposite the sign, and then k is 1. So the easiest thing to do is just right here, right off the bat, my asymptote is my k value. So y equals 1. So I know I'm having a horizontal asymptote right there at 1. Next, our first reference point is just our h value. So our h value is 2. And then a plus k. So our a value of negative 3 plus our k value of 1. So we have a first point is at 2, negative 2. So 2, 1, 2, negative 2. Down there. Then our next one says, okay, it's whatever your h value is plus 1. Running out of space. I'll put it up here. Our second reference point is 1 plus our h value 2. And then it's our a times our b, so negative 3 times our b value of 2. And then plus k. So that would be 3. And then negative 3 times 2 is negative 6. Plus 1 is negative 5. So we go ahead and graph that one. 3, negative 5. So then we connect it. So it's always going to be, this is my first reference point. This is the one that's going to my asymptote, and then extending away from it this way. So it looks like this. Now, the other thing we want to do, so that's our graph. We're done. Then state our domain. Domain is our x values. Does the graph go to the left? Yes. Does it go to the right? Yes. It'll never stop going. So my domain is all real numbers. Or we could say it goes from positive infinity to negative infinity. My range, does my graph go up? Yeah, but it actually stops here at 1. Okay? And this line of 1, does it go below it? Yep, so we'd say y is less than 1. You come to here, again, identify a, b, h, and k. So my a value, I'll put it up here. So my a value is the first one, 1.5. My b value is the base of 10. My h value is negative 3, so it'll be positive 3. And then my k value is that 5. So it's negative 5. So first thing we do is our asymptote. So we have y equals negative 5. That's my asymptote. So I come down here, we're counting by 2. So 2, 4. So negative 5 is down here. Then we go ahead and identify my first reference point. Again, I'm just using this here. My h value, so h of 3. And then a plus k. So 1.5 plus k of negative 5. So that would be 3. And then 1.5 plus negative 5 would be negative 3.5. Then my second reference point is my h value plus 1. So 3 plus 1. And then a times b, so 1.5 times 10 plus my k value of negative 5. So 1.5 times 10, that would be 15, plus negative 5, which would be 10. So these are the points I'm going to graph. This is my first reference point, so 3. Again, we're counting by 2, so 2, 3, and then down, negative 3, so negative 2, 3.5. And then we go ahead and we have 4, so 4, and then 10. So this is going to, again, this is my first reference point. This is the one that's going to go to it, and then it climbs like that. Again, we want to state our domain and range. Does the graph go to the left? Yes. Does it go to the right? Yes. Does it ever stop? Nope. So it'd say all real numbers. My range, graph opens up now, so we'd say y is greater than this value right here, which was negative 5. As we go through. So first thing we're going to do is graph. The next thing we're going to go ahead and do is we're going to, given a graph, we're going to write an equation. I'm going to put this, what we're going to need for this is just this reference point here. Remember, our asymptote is our k value, and we're going to use this h value and then a plus k. So we'll go ahead and do the next two on here, writing the equation given, so right here. So given here. So given this, we want to write an equation. So first thing we're going to do is, I need to know A, B, H, and K. It says, it also what may ask for your domain and range. Remember, domain, it goes to the left, goes to the right. So my domain here would be all real numbers. My range for this one, it would be, see right here, it has my asymptote, y equals 1. So I know that's going to be everything less than that. So first of all, I can go ahead and put that in. That's my k value. Next, they say b is 2, so I put that in. So now I'm just going to use this reference point. The first one, this point, which is closest to my asymptote, is found using this. So this right here is my h value. And then to get the negative 1/3, I got to go a plus k. So I know h is negative 1/3. So now all I need to know is my a value. So to get it, I go a plus my k value, which I know is 1, equals negative 1/3. And then I solve for a. So I subtract 1, subtract 1. So a equals negative 4/3, or you could say negative 1 1/3. So now I write my equation. Y is equal to my a value, negative 4/3, times my b value of 2, to the x minus negative 1/3, so that would be plus 1/3, minus my, or plus my k value of 1. So there's my equation as you go through it. For number 2, we go through, again, doing the same thing. Where's my asymptote? There's my vertical line or horizontal line right there. It says my asymptote is at y equals 5/2. So I again identify A, B, H, K. That's easy enough. They tell me it's at 5/2. Oh. Negative 5/2. So this right here is negative 5/2. You could say that 2.5. Then I go through, they tell me my b value is 2. So then I go to my first reference point, the point closest to my asymptote. So that's 3. Again, that's my h value, is that 3. So, and then it's a plus k, gives me that negative 1. So I go a, my k value is negative 5/2. Again, you could put that as 2.5, equals negative 1. So, then I add negative 5/2, add negative 5/2, and so my a value is equal to, I would just turn this, add 5/2, there you go, add 5/2 to it. So this would be negative 2 over 2, so 5 minus 2, so it would be 3/2. And now we can go ahead and graph this. So, or write the equation. Y is equal to my a value, 3/2, times my b value, 2, x minus my h value, and then This is negative, so you'd say minus 5 halves as you go through it. Again, you could write this as 1.5 and this is negative 2.5 if you'd like. Either way will work, but that's what we're going to be doing. So we're going to be writing the equation, and then we're going to be graphing the equation. So again, exponential growth, remember it's steep curve going up or steep curve going down. We're going to use A, B, H, and K to graph these.